factorising, the answers that you could have had here, because they're both even, you could have had 2 and then 6x plus 9y. But the thing that we looked at yesterday is we're saying you've got to get the highest common factor, the biggest number outside the bracket. So if you get that, you will actually get one of those 2 marks. But to get the full 2 marks, you need to find the biggest number that goes into 12 and 18, which is actually 6, because you could have also got 3 and 4x plus 9, not 9y, 6, 6y. So it should have been 6, this is the one you wanted, 2x plus 3y to get you 2 marks. Okay? Again, this one here, we had a carbon copy of one of those come up yesterday. So we need to make sure we can do these ones, okay? We may do, at some stage today, just practice nailing a couple of questions like this because we've seen it come up a couple of times. Because this is getting divided by a, to get rid of it, we need to times by the a. So the next line you're looking for is 8 equals 24a. And then to get rid of the 24, we need to divide it because 24 is times in that a. So we get 8 divided by 24 equals a. Now that should be enough to get you the full mark there, but some people will want to put it into their calculator and say 8 over 24, and they'll get the answer of 1/3. So 1 over 3 equals a. Obviously you could press SD and you get 0.3 with a dot on its head or 0.33333. Obviously a 1/3 looks nicer than that number there in my calculator. That's why people tend to leave it as a fraction. It's absolutely fine to leave it as a fraction. It doesn't say anywhere in the question, write in simplest form. So it's fine to leave your answer as that. That would get you the mark, okay? This one here, solve the equation. The thing you've got to be careful with here, we're always looking to find the smallest amount of a and take it away. So we're looking to get rid of this 2a here. So that means we're going to be taking it away from this side here. So we get 8a, take away 2a. This plus 7 here we want to get rid of from this side, so we get the a's on one side, numbers on the other. Because it's a plus by here, on this side it's going to be a minus. So we get 34 minus 7. Okay? Next thing I'm going to do is work out what 8a take away 2a is. That's 6a. And then 34 take away 7 is 27. And then to get rid of the 6, I need to divide by the 6. So I get 27 divided by 6. And again, that would be full marks. If you want to, you can put it in your calculator and see if it goes any nicer, because you've got the calculator for this. And it gives me 9 over 2 or 4.5. So again, either of those answers, that would get me my full marks. But I could have written 9 over 2, or I could have written a equals 4.5. Okay? The next one are ones that we absolutely love because we've just got to make it look exactly the same in the calculator. And then for right that answer, again, minimum 1 mark. 2 marks if we do what it says correctly. So, first of all, I need to press the brackets. I'll try and show you what I'm doing. So, bracket first, then the fraction button. So, 8.2 minus 9, 8.2 squared minus 9.9. And that cubed on the outside, so I don't cube that. I need to put over 6.5. Bring that round to the side, bracket there, and then cubed by there. So, that looks identical to what's in the question. Press equals. Always write down whatever's in your display because you will get one of those 2 marks for that. So 4880725. And to 2 decimal places, we're looking for the decimal point, 1, 2, line goes down there. That 8 will change that into a 9. So I get 0.49 to 2 decimal places. Okay? That's got me another 2 marks, so my total marks available for that page was 8 marks. So we're 8 marks into the 33 already. The scattergraph, when I first saw that, I thought it was a little bit sneaky because we're used to plotting those points and finding out all the values. But then I thought, you know what? You'd only get 2 marks for plotting all these values anyway, and they're giving us 2 marks just for going and finding the missing values. Okay? I'll go for this one first, just because it comes first in the table. So, before I start trying to work out where 5,300 is, I need to work out what the scale is. So, from here, how much is that jump 200 to 300? You've told me the next bit. Jump from 200 to 300?
Oh, that's the other one, isn't it?
100. How many little squares fitted into that? 20. Okay, so if you do 100 divided by 20, that will tell you that it's 5, and 5 is what the value is of 1 little square. You don't need to write this down, but you certainly need to be aware of it.
Do you know what this colour is?
She's at the back there. In terms of this one, how much have I jumped up this time from 3,000 to 4,000? 1,000. How many little squares fitted into it? 20. So 1,000 divided by 20, again, stick it into your calculator if you're unsure. It's absolutely fine. You've got a calculator during this test. 1,000 divided by 20 is 50. So one little square going up here is worth 50. So if I'm looking for 5,300, here's 5,000 by here. This must be in between 5,000 and 6,000, so that must be 5,500. So 5,300 is going to be in this bit here. You're not too on, do you? I've got a strip of light, as you saw. Better? Yeah. So if I'm there, 5,000, so that'd be 5,050, 5,100, 5,200, 5,300. I'm looking along this line here for a point, and I can spot it there. So I need to come down and read off what that value is. So if I come down to my scale here, don't need to necessarily draw a line, but I am just going to try and make it point out really quickly. We know that one little square is worth 5, so 405, 410. So I'd write down here, 410. So if you got that, well done. 400 wouldn't get you the mark, it's got to be 410. Okay? And for the other one, 425, if I look for 425, that is going to be 5 little squares in, or I could have said in between 400 and 500 is 450, so 425 is in the middle of those two. So I'm going to draw a line along there. It's in the wrong... There we go. Oh, this is harder than it looks. Right, is that okay? Ish?
Unsubscribe.
It's the best thing you've said in a couple of months ago. If I look along the 425 there, I can see that there's 2 points on that line. This point here and this point here. So that means one of them must have already come up. So if I look along my table, here's 425 there. So the 5,750 has already come up. So if I look for that one there, that's in between 5,500 and 6,000. So that must be the bigger one. Is it back? Good. So that one must be the one that's been already plotted. So I need to work out what this value here is. And I've already said by here that 5,500. So that's 5,500. So I'm just reading off that line there. Okay? So come back down to my table. Should have 5,500. Okay? Over the page, part B, it says describe the relationship between the number of visitors to the theme park and the entrance fees collected. We're looking for the correlation there. Anyone know that? Positive? Excellent. Okay.
Just the word positive will get you a mark for that as well, right? So just the word positive.
The next one, C, is something that you may not have done recently, so it may be a little bit alien to you. When we're looking at drawing the line of best fit, usually we get, it says at the start of the question, it says, by eye, draw a line of best fit. But when you're actually drawing a line of best fit, what you should do is you should work out the mean point and draw your line of best fit through that. But they've told us what the mean point is. It says the mean number of visitors per day was 375, and the mean of entrance fees collected was 5,100. Draw a line of best fit on the scatter diagram. So if you just went to a scatter diagram and just drew just your generic line of best fit like we normally do, without it going through that point there, you'll lose one of those 2 marks. You'll still get 1 mark, but you'll lose 1 mark. Okay? So I need to go and plot the point 375. So 375 is going to be in between 350 and 400, so it's this line here, and then 5,100. So I'm on that middle line there, and then 5,100 would be 2 little squares up here. And to show that's the mean point, and I plotted it, you put a circle around it. Okay?
So is this supposed to be in line with the 350?
375, I think it was, wasn't it? Should go and check the question, it said 375. Yeah? So when I'm drawing my line of best fit, it's got to follow the general trend of the data, so that's somewhere like this, and my ruler has got to go through that point there. So it's going to go something like that, but what best follows the trend of the data. And remember what we talked about yesterday, it is a misconception that it needs to go through the origin here. It does not need to go through that point. If it hits here, that's fine. Okay? So something like that. And for the next bit, it said estimate the entrance fees that should be collected on a day with 300 visitors. Now you would get this even if you hadn't done your line of best fit correctly in the last one, as long as you're showing what you've done. So 300 visitors, I'm coming up to here, and then I'd come off my line and work out what that is. Okay, so an awful lot of scale work on this question. If that's 4,000, 5,000, in the middle here is 4,500, and I know one little square is worth 50, then I'm coming down 2 little squares, so that would be coming down 100, so my answer would be 4,400.
So
Okay.
I am 4,400.
Fine, as long as it's been read off your line, fine. Okay? So one of the things we said yesterday, you can have like a few different answers there, as long as you've read off your line correctly, that isn't a problem. Okay? I've written down Will's answer. 4,400 on my work, okay? Okay then, so over the page, so remember this was missing a line that didn't come through on the photocopy for some reason. And when I was looking at the board, I made it that line was joined up to here. And it was a dotted line that you should have had there. So this should have been on your work already, I'm just adding it in, okay?
Doesn't matter if it's not dotted.
It doesn't matter if it's not dotted. Okay. First question, it said, for how long did cyclist A stop to mend the puncture? So the line where it goes flat would suggest that it's not moved at all from the distance from the start. So I'm looking how long this is. So it's at 10 o'clock that he gets his puncture, and then in between 10 and 11, so that must be 10:30. So for how long? 10 to 10:30 is 30 minutes, or you could have said half an hour. Okay, either of those are fine to get the mark.
Check the question, make sure it doesn't ask you to do it a certain way. So doesn't.
It says, at what time did cyclist B pass cyclist A? So that is at this point here for me. Okay. Now it depends how you drew your line in, so you may get a different answer to me. First things first, how long is this gap here between 9 and 10?
An hour.
An hour. Okay. Now I want to have it in 60 minutes because how many little squares feed into that gap there? 20. If I do 1 divided by 20, I'll get like 0.05 hours, which isn't really going to help me, but you're right when you say it's an hour. We'll write it as 60 minutes just to make it slightly easier with us to do the calculation. So 60 divided by 20, because of the 20 little squares, tells me each little square is worth 3. So I'm looking at this point here, because that's on my drawing where they cross, but ideally that line would have come out. You won't have this issue in your actual exam. And if I come down here, I can see that it's 3 little squares on from 10. So that's be 10:03, 10:06, 10:09. But when I did it before, I actually had 10:06. So as long as it's where your actual line crosses, that isn't a problem today, okay? That's why I was expected to get either one of those 2 answers. I felt question C would be very, very easy to make a mistake on. It says, cyclist A restarted after mending his puncture. How many kilometres ahead of cyclist A was cyclist B at that time? So if we look to see where he's restarted, he is restarted by here, and cyclist B is by here. So I need to come and work out exactly what that distance is. So if I draw a line across there, anyone tell me what that value is there? 16, fantastic. If I wanted to, I could go and work out my scale again. So I've gone up a jump of 5, divided by 10 because there was 10 little squares. So each tiny little square is worth 0.5. So that'd be 15.5, 16. So if he's on 10 and the other guy's on 16, how far ahead is he? Fantastic, 6 kilometres. If you got that well done, I thought that was sneaky. And for the last question, it says both cyclists finish at the same time. Calculate the speed in kilometres per hour that cyclist A was travelling after he restarted. So the first thing I'm going to draw down is my triangle that says speed equals distance over time. Just so I can remember what the formula is, I'll remember that triangle. So the speed will be equal to my distance divided by my time. So in that time, cyclist A was at 10 and he's got to this point here. So I need to work out how far he's travelled from 10 up to here, which is 24. So that distance is 10 to 24 would be 14 kilometres, okay? But I know someone else got 13.5. It's fine, whatever you've read off your graph, because you weren't actually given that line on the other, so you had to draw it in, okay? So the distance would equal 14 kilometres. And the time, now be very careful, in the question it says calculate the speed in kilometres per hour. So my time shouldn't be 30 minutes because it said it in hours, so that is 0.5 hours. Well done. Okay, and that's something that goes into your calculator.
Yeah,
And it comes out.
But don't try and do stuff in your head, you've got to have it in front of you. So.
28 kilometres per hour, or kmh is what we write. Over the page, quality of written communication, how many marks is that worth? 2 for the quality of written communication, 4 for the maths. I thought this was actually a very, very nasty ratio question, okay? It's important that you read the question fully to make sure you understand what's going on. It says, a name I can't pronounce yet again is organising a party at her house and would like to invite 30 guests. A fruit drink on arrival. The recipe for the drink requires lime juice and orange juice in the ratio 1 to 5. So what I would write first of all is lime, ... orange, because whatever order is given in the question, that will follow that ratio. So underneath I'd write down 1, ... 5. Okay? It says that she plans to give her guests 250 millilitre of the drink. She has plenty of lime juice. The lime juice isn't a worry. But she only has 6 litres of orange juice. Decide whether or not she has enough orange juice to make the 30 drinks. Okay? Now with ratio, the first thing you should always do, step 1, you should always add together the numbers in the ratio. So 1 part lime juice to 5 parts orange juice would give me 6 parts in total. The next step I do is I do the drink, 250 millilitres, divided by 6. And this is why I thought it was a horrible question. 250 divided by 6 doesn't give a nice answer. Now for me, that's a bit of a weird answer to think of when we're trying to think of then 30 lots of that. So I would actually have this as a decimal, even though usually with a 0.6 reoccurring I don't. But I would leave it in a decimal to try and give me some idea of what's going on here in terms of the 250 millilitres. So that's 41.6 reoccurring millilitres, and I put a brackets there for 1 part. How many parts was orange? 5. So what am I going to do to that? Excellent. So I'm going to do 41.6 reoccurring times 5. But there's a very neat trick for doing that in my calculator. Whatever that previous answer was, I just say times 5, and it will keep it in my calculator. Again, weird answer. Press SD. That equals 208.3 reoccurring millilitres, and that would be for 1 drink now. Okay? So I'm working purely on the orange here. How many drinks did I want to make altogether? 30. Fantastic. So I'm then going to do the 208.3 reoccurring times 30. So again, the trick on that is I just press times 30, and I get the answer 6,250 millilitres of orange altogether. How much orange juice do I have to begin with? Remember?
6 litres.
Well, fantastic, Sam. I was going to say 6 litres, but Sam, you've already converted that into millilitres, which I need to because this is in millilitres, which is 6,000 millilitres. So do I have enough orange juice?
No.
No. Okay. I'm going to show you Sir's way. So you've done it a slightly different way, haven't you? You want to explain your way? 6, which is not enough to make 30 drinks. Okay, have I got the full marks there? 6 out of 6? No, Joe, what do you think? I need to annotate it, okay? I need to say what I'm doing, etc., etc. So arrows here. I've started doing that, and I've used units throughout. I've used millilitres throughout. And as long as I'm doing that, I'm definitely going to pick up one of those marks, okay? But I do need to annotate that properly. I'm going to let Sir jump in quickly and give his answers. It's slightly different from mine.
Okay, so I'll show you just the way I've done it. Started off in the same place. So we've got the lime, to the orange juice is 1 to 5. Okay, just like we said. This time I've said, I know I've got 6 litres of orange juice available. Okay, so that equals 6,000 millilitres. So I know my total amount I can make is going to be using 6,000 millilitres of orange juice. So what I do then is I think, how do I get from 5 to 6,000? So what is the jump from 5 to 6,000? What do I multiply 5 by to get 6,000? The way I do that, with my calculator, I do 6,000 divided by 5, gets me 1,200. So to keep it consistent, I multiply this side by 1,200 as well. So that's 1 times 1,200. Can you calculate for that? So what I'm saying now, for 6,000 millilitres of orange juice, I'm going to need 1,200 millilitres of lime. So my total amount of drink is both of them added up together, because they're mixed together, aren't they? So 1,200 add 6,000 equals 7,200 millilitres. So that's how many millilitres of drink I can make with what I've got. Okay? And I want to share that between 30 people. So I'm going to see if I was to share that amount between 30 people. So 7,200 divided by 30. That makes 240 millilitres. So every drink then will be 240 millilitres. I need every drink to be 250 millilitres, don't I? So I haven't got enough. Unless I give my guests 10 millilitres less. Okay?
We'll just water it down to...
Or you can just water it down.
Yeah.
Okay? Depends how much you like friends. Okay? Depends if you want to come back.
Okay, so interesting, very, very different way of mine doing so, whichever one works better for you. Okay, so over the page. Okay, now this one here, I felt again this was sneaky. It wasn't quite as obvious as what you needed to do. When we were talking about substituting yesterday, what I told you I wanted to do is to change every letter to open brackets. Okay? Now you've got 2 ways of doing this. You can either try and think it through logically, and if you're there thinking, I've got no idea, just start chucking in the numbers in some sort of random way and seeing if you can get the smallest possible answer. I went for option A, using a bit of logic, and I thought, to get the smallest amount, because it says what's the least possible value that I can get when I use 10, 6, 3 and 4, I thought I want to have the smallest amount. So think about it, if you had a cake and I had 1 cake on the show between me and Mr. Jones, we have half a cake each, happy days. If I want to invite Miss Cowley to the party, we'd only get 1/3 of the cake. Less cake for us. Unhappy days.
Joint cake.
Yeah, it'd have to be free from, wouldn't it? If we invited you all to the party as well, we're going to get like a crumb of cake. Okay? So in terms of what I've got, the smallest number being on top, the more I have on the bottom, the less I'm going to have. So I looked for the smallest number out of these, which was 3. So that's a square there, sorry. And then I thought, right, I want to get the biggest number on possible, so biggest number on the bottom as possible. So I knew that timesing 2 big numbers together would give me an even bigger number, so I chose 10 and 6 here. And then I only have 4 left. And then if you try just subbing in the numbers in a different order, trust me, it won't get any smaller than what this offers. So the way I put this into my calculator, fraction button, open brackets, squared, and then open brackets, plus open brackets. And like I said, you can chuck the numbers in any order. The order I went for was 3 there, and then 10 there, 6 there, and 4 there. And when I press equals, I get 9 over 64. That doesn't really help me in terms of me thinking, is that the least amount possible? So I would press SD and look at that as a decimal, 0.140625. If I then put the numbers in a different order, for instance, if I put 10 up on here, so that would mean that I have to have the 3 down here instead, I actually get a much bigger number than a fraction. I get 4.554 repeated. Okay, so obviously that one's not smaller. Okay, so it's up to you whether you want to have a play and see if you can find a different one, or you can try and use a bit of logic. So for me, what I'd need to do now is match up what these things were here. So the 3 belong to M, so in my answer, M equals 3. Now P could equal 10, but it could have been 6 as well. It doesn't actually matter which way round you have those two, because as long as you have the next one, the 6 times 10 times 10 times 6, they give the same answer. So this would be 6 or 10, whichever way round you had those. And then your T was 4. Okay? So the answer to that, to give my least possible value, was 9 over 64, or 0.140625.
You've got to reach this in a fraction, it says in the question.
Does it say in a fraction? Write this value as a fraction, so don't write that, even though it's useful to compare. Okay? Next one, I know you all couldn't believe your luck when that came up, because we spent ages on it yesterday. It says, shade the region in the trapezium below that satisfies both of the following conditions. It is closer to A than to B. It is less than 5 centimetres from B. So what we need to do to work out if it's closer to A than B, I'm going to highlight where A and B are. I need to get my compass, I need to open it to just more than halfway. Drastically more, just more than halfway. Okay? So for me, that's obviously more than halfway. I'm going to bring it back a tiny little bit. And then I draw the semicircle like that. Opening the compass, moving it around the other way. Do not change the width. And then round that bit there. Okay? Then through a ruler, line up both those points there, there. Now everywhere on that line has an identical distance from A to B. So if I looked at this point here, if I measured a distance to A, I'd expect it to be exactly the same distance to B, and I could actually go and prove that using a ruler. So to get the points that are closer to A, it will be everything this side of the line, because A is by here. Obviously everything this side of the line will be closer to B. Okay? The second bit said it is less than 5 centimetres from B. So at B, I need to open my compass to 5 centimetres. Okay? And then I draw full circle around B, which is harder than it looks with a compass above it. Now everywhere on that line is exactly 5 centimetres from B. We looked at an example yesterday that said further than 5 centimetres from B, but this one said less than 5 centimetres from B. So it wants everything inside this circle. Okay, so it's got to be this side of the line, but within the circle. And you've got to pretend that this line here doesn't exist. That's just my construction lines from the first bit to then cut it in half. So it should be all of this bit here shaded, but I'm going to stop by there. Why am I stopping by there? Any idea? Excellent. It says in here, inside the trapezium below, just above. There. Inside the trapezium below. So it's got to be within here. Okay? So that was the area that you're expecting to shade. Okay? Okay, question 7. I'm actually going to skip elements of this, because I didn't think it was a really obvious question, and this is what Sir alluded to at the start. They're not necessarily going to be really easy up until the staples in the middle of the paper. Part A I thought was reasonable enough. It said 1 week a PE teacher recorded the times taken by pupils from 2 PE classes to run 100 metres. The frequency polygons show the results obtained below. It says a prize was given to one of the groups. The PE teacher awarded the prize to group B. Without doing any calculations, give a possible reason why the PE teacher decided to give the prize to group B. Do anyone think the reason why?
They have the lower times.
They have the lower times at the highest peak. So they peak all the way up by here, which is the quickest time. Okay? So all I'd say is group B had quicker Now, if that's the most common one, what's another word for the most common? Excellent, well done. You can say I have the quicker mode time, or modal time. In terms of part B and part C, we can come back to again, but I thought it was very time-consuming. I didn't think it was actually that obvious to do, okay? So I've just skipped on from there. And then again with question 8, I looked at that and I thought, that's going to take ages. That's the sort of question that we're not going to be annoyed if you come out on Monday and go, oh, question 8 was hard. Yes, it is, okay? So I'm going to just carry on and see if there's any more marks that I think are accessible. And I think this is accessible because we did something very, very similar yesterday. And when I saw it was 6 marks, I thought, actually, that's pretty good. To work out perimeter, what is perimeter?
Outside the circle.
Excellent. The outside of a shape in general. It could be a circle, it could be a triangle. It tells me that the perimeter of the triangle is equal to the circumference of the circle. So circumference is just a posh word for perimeter of the circle. Calculate the radius of the circle. Well, first things first, I need to work out what the perimeter of this triangle is. So how would I work out the perimeter of this triangle? Fantastic. I've got to find the missing side. And to do that, I need to use Pythagoras because it's a right-angle triangle with 2 sides. I need to find the third side. So I'd be expecting to see a squared plus b squared equals c squared. Okay? Now c is always the hypotenuse, so I'm just going to write c in there. So I'm going to have 10 squared plus 24 squared, or vice versa, it doesn't matter which way round. That gives you an answer of 676 when you type that into your calculator. And then to get rid of the squared, I'm going to square root. Fantastic. That goes into my calculator, and again, don't worry, I'm not doing this off the top of my head, I've done it before, I just remember the answer. 26 centimetres is equal to C. Okay? So I'm going to go back to my shape by here, and just say equals 26 centimetres. So now I can work out the perimeter by, fantastic, adding all the sides together. Okay? So I'd write just underneath, perimeter P equals 26 plus 24 plus 10. And that equals 60 centimetres. So I know the distance around this circle is also 60 centimetres because we're told that they're the same. Okay? Now when it comes to circles, you should be remembering 2 key formulas. One for area and one for circumference. Can anyone remember either? Pi r squared, that's the area one, because think of area being centimetres squared, the one with squared in it belongs to area. Okay?
2 pi times r.
2 pi r, fantastic. I really like it that way around because these two look very, very similar. That 2's just jumped to the front, and we know that when we're talking about a distance, which circumference is, can't have a squared in it. That's how I remember it personally. It's not the only formula though. Will, you have another one? Excellent. Or pi d, whichever one works for you. Okay, it doesn't matter. You just got to remember that the diameter is twice as long as the radius. Okay. So to work this out, I'm going to work with, is there any preference in here? Anyone want me to work with either one of these 2 formulas? Anyone want to vote pi d? No, I'll work with 2 pi r then. Okay? The reason why I'm going to work with 2 pi r is because in the question it says, calculate the radius of the circle. So circumference is equal to 2 pi r. Now really, that is 2 times pi times r. I know what the circumference is. The circumference is 60 because it's the same distance as the triangle, the same perimeter as the triangle. So that becomes 60 equals 2 pi r. Okay? Now I want to get the r on its own, so I want to get rid of this 2 pi. And that 2 pi is multiplying the r. So when I take that over, it will become x, and it will become divide. So I'm going to get 60 divided by 2 pi. And that will tell me what the value of the radius is. Okay? So again, fraction button, 60 over 2 pi equals do I need to write down the whole number?
Yeah.
It's up to you. It didn't say to round it. You would get full marks for that. It's nicer to round it to maybe 1 dp or 2 dp just so you don't have to do so much writing. Okay, but it didn't say anyway you had to round it. So I'm just going to say to 1 dp. If you do round it, it's important you say what you've rounded it to.
So if you don't write the
1 dp.
together, no, the one before the full number, you might get 6.
No, you get the full marks.
The only thing you should try and do is write the first one just in case you messed around with that.
Yeah.
Say you just wrote the rounded one and you got it wrong, according to Henry Mount, wrong answer. If you've done it That's right, and then you round it wrong, you're not going to lose anything. Okay.
Sam?
Can you calculate? Sorry, I can.
Of course, Cam.
Right.
All good. But yeah, 6 marks. I thought that was quite a nice 6 marks. I didn't think that was that bad. As long as you knew your Pythagoras, as long as you remembered your formulas for a circle, it was a case of just trying to show as much work as you possibly could. We got 6 marks. Okay. Over the page, again, a very, very easy 1 mark here, but then to do the rest of it, potential to make mistakes. It says calculate 2.9 times 10 to the 12, blah, blah, blah. So basically put that into your calculator as it looks. The fraction button, 2.9 times 10 to the power of 12, and then 7.1 times 10 to the power of 4. Press equals, and write down all of that number. 4084570.42. Okay? 1 mark in the bag. You've got to know what significant figures are. They're not the same thing as decimal places. You start counting as soon as you see your first non-zero number. So is that 4 0 or not?
No.
It's not 0, so I start counting. 1. Now that means because I started counting, I carry on counting. So I don't say, oh, now that's 0, I skip 1. Because I started counting 1, 2, so my line goes down here in between the 0 and the 8. Okay? What is that 8 going to do to the 0? Excellent, round it up. So that becomes 4, 1, and then how many numbers up until the decimal point? 1, 2, 3, 4, 5, 6. They all change to something.
0.
Zeros, fantastic. 1, 2, 3, 4, 5, 6. I could put 0.00, there's no point. I know after a decimal point there's loads of 0.0s. Okay? Have I written my answer in standard form? That's my 2nd mark now. No, so to write it in standard form, it's got to be a number between 1 and 10. Less than 10. Go on. 4.1, fantastic. 4.1, it'll be times 10 to some value. To work out what that value is, the decimal point is by here. How many jumps for it to be in between the 4 and the 1? So 1, you've already done it for me. 7, fantastic. 1, 2, 3, 4, 5, 6, 7. Let's stop there. Well done. There you go through that bit. Yeah, absolutely fine.